We've looked at different ways to model motion, and now we're going to look at how we can use graphs for our modeling. So the first graph we're going to look at is a displacement time graph, and it's used to represent a particular type of motion. That object, just screaming across the screen then, is moving from point A to point B in a given amount of time. So it's travelling at constant velocity. What we want to know is, if we graph that motion, what will the graph look like? So let's draw in our axes, displacement over time. Now when we're graphing, we always try to graph the equation. So I'm sure you can think of the equation that relates to displacement and time. Now if we get a straight line result for our graph, what will the gradient be? Well, we can work out the slope of the gradient by rise over run. Displacement divided by time. Y-axis divided by the x-axis. The y-axis is going up, rise. The x-axis is going across, run. So we have rise over run, and so we'll plot that. Now we'll plot the run, and what we end up with is a triangle. The hypotenuse of that triangle will give us the slope, and it fits an equation that we know. Velocity equals change in displacement over change in time. So that's how we can graph velocity. Do a displacement over time graph, and it's constant velocity. It will be a straight line. But what about this one? This is a displacement over time graph. What is happening on this graph? Have a look at it. What we have is a body at rest. A body that is stationary at a certain distance from the origin, its displacement. And what about the graph at the bottom of the page? What's happening here? Have we still got a velocity graph where we've got displacement over time but a curved line? Well, let's have a look. So the gradient could be in any number of positions, and the point at which that line touches our curve, in other words, the point at which the blue line is tangent to the red line, is our instantaneous velocity. So clearly this object is changing its velocity, and we know that if we have a changing velocity, then of course the body is accelerating. So the different shapes that we've looked at of a displacement time graph could be constant velocity, a body at rest, or a body that is increasing or changing its velocity, which of course would be acceleration. So if we were to now graph velocity over time, we know that change in velocity over time is acceleration. So what should we conclude if we have a straight line as a result of our velocity over time graph? Well, just like with the previous graph, the straight line means it's constant or uniform, and of course it's uniform acceleration. And also, like our previous graphs, we can work out what that acceleration is by calculating the gradient as rise over run. Change in velocity over change in time, and of course we know an equation that fits that model. Well, what's happening in this graph? I've got a graph at the bottom of the page, velocity over time, but this time the line's not straight up and then stop. So we've got lines 1, 2 and 3. Have a think. What do you think lines 1, 2 and 3 might represent? Of course, the first one is uniform acceleration, just like the graph at the top of the page. The second one, just like in our displacement over time graph, where a horizontal line meant it's not really going anywhere, horizontal line in this case means it's not accelerating anywhere. It's constant velocity. And then line 3, it's acceleration in the negative direction. Now here's something new for you. The area under the graph also has a meaning. And we can think of it actually in terms of our equations. The area under the graph is actually our displacement, the total distance travelled. So here's a question for you. Here we have a velocity over time graph, and we've got 3 positions, 3 lines on the graph. Can you use this graph to find the acceleration, the maximum velocity, the retardation, which simply means the deacceleration rate, and the distance travelled? So now you should go to the quiz and do your best to answer these 4 questions. Go back over the PowerPoint as many times as you need to think it through, and I'll give you a clue. Look for the gradient in each of the blue lines and look for the area under the graph.